When you go from 32-bit to 8-bit, you reduce the memory required for every single parameter by a factor of 4. That means the model becomes 4 times smaller. Just like that, a 40 GB AI model becomes a 10 GB model. That 4 times reduction is the breakthrough that makes running AI locally realistic. So, you download one of these powerful new AI models. You're excited to run it, and your computer basically just says, nope, it's too big. That's a super common problem in local AI. But there's a clever solution that lets us shrink these digital giants down to a size we can actually run on our own machines. In fact, we can shrink them by up to 4 times. Let's break it down. Researchers call it the Gigabyte Gap. The yellow line shooting up shows the explosive growth in AI model size. The little white squares represent the memory in our best consumer hardware. The issue is obvious. AI models are getting bigger much faster than our computers are getting more powerful. That widening gap is exactly why running the latest AI model locally can feel almost impossible. So how do we bridge that gap and actually make these models 4 times smaller? We use a technique that acts like a shrinking ray for AI models. It's called quantization, and it's the hero of this story. Quantization is what makes massive AI models accessible on everyday hardware. At its core, quantization is simple. An AI model is made up of extremely precise numbers called weights. These numbers define how the model thinks. Quantization takes those highly precise numbers and represents them with simpler, less precise ones. The result is a much smaller AI model file, often without a noticeable drop in performance. A typical full-size AI model stores information as 32-bit floating point numbers. Think of them as numbers with a lot of decimal precision. Very accurate, but very memory hungry. Quantization converts them into smaller formats, like 8-bit integers. Yes, it's a trade-off. You lose a small amount of precision, but in return, you get a massive reduction in AI model size. Here's the real impact. When you go from 32-bit to 8-bit, you reduce the memory required for every single parameter by a factor of 4. That means the model becomes 4 times smaller. Just like that, a 40 GB AI model becomes a 10 GB model. That 4 times reduction is the breakthrough that makes running AI locally realistic. Now that we can shrink models with quantization, how do we actually use them? We need a file format designed for quantized AI models. The modern standard is GGUF. Think of GGUF as the universal key that unlocks local AI. GGUF is popular because it's practical. First, it packages everything into one portable file. The model weights, the vocabulary, the settings, no more hunting for missing pieces. Second, it supports extensible metadata, which means new features can be added in the future without breaking older models. And finally, GGUF powers popular local AI tools like Ollama and LM Studio. You might still see an older format called GGML. Here's what you need to know. GGUF is the new and improved version. GGML was an important first step, but it was known for breaking often. If you have a choice, always download the GGUF version. It's the stable, modern standard for running AI locally. Now let's talk about the most practical part of all this. When you download a GGUF model, you'll see a list of files that looks like alphabet soup. Q4KM, Q80. It's confusing at first. So what do these codes actually mean? These file names represent different levels of quantization. They directly affect AI model size, speed, and quality. Let's start with Q4KM. This is the 4-bit version, and it's the recommended starting point for most people. It hits the sweet spot between small file size and strong performance. If you have more RAM available, stepping up to Q5KM gives you a noticeable quality boost. If you have a powerful machine and want quality that's closest to the original model, Q80 is your best option. On the extreme end, Q2K is designed for devices with very limited memory. You may also notice two main quantization families. The versions with a K in the name are called K-quants. They're designed to use bits efficiently while maintaining high quality. More recently, I-quants have appeared. They use lookup tables to achieve even smaller file sizes, sometimes at the cost of speed. For most users running local AI, K-quants are the safest and smartest starting point. Now, how do you choose the right quantized AI model for your hardware? First, we need to understand how quality is measured. When we shrink models through quantization, we introduce a small amount of loss. The technical metric for this is perplexity, or PPL. You can think of perplexity as a stupidity score. Lower is better. A lower PPL means the quantized model behaves more like the original full precision model. Here's your simple guide. When in doubt, start with Q4KM. It's the gold standard for a reason. It offers the best balance of size, speed, and quality from most local AI setups. If you have extra RAM and want better results for coding or detailed writing, move up to Q5KM or Q6K. And remember this: smaller model files do not just load faster. They leave more RAM available for the actual conversation. That means longer chats, more context, and better performance before you hit memory limits. That's what this is really about. Quantization and the GGUF format are the technologies that let us shrink AI models by up to 4 times and unlock powerful local AI from millions of people. These AI models are no longer reserved for massive companies with giant data centers. You can run them on your own machine, which leaves one final question. What will you create?